Kurt Johnson to talk about fresh air ventilation and specifically energy and heat recovery systems. So I want to start just quickly with a quick introduction of the BrightBuilt team members that are with us today, and then we will hand it over to Kurt to take it away for his excellent presentation. I'm Parlin. I am the director of BrightBuilt Home. I've been here since the firm launched in 2013, and really excited to continue to see the growth and potential in the firm, all of the things we have coming down the pike in the near future. So I'll hand it over to Jay next to introduce himself.
I'm Jay Sandifer. I'll be likely the first person you talk to as I handle the sales here at BrightBuilt. Looking forward to Kurt's presentation today. And on to Jessica, please.
Hi, I'm Jess. I work at BrightBuilt as a project coordinator. I've been with BrightBuilt for over 5 years now, and I will hand it to Audrey.
Hi, I'm Audrey Rolio. I have been with BrightBuilt for almost 2.5 years. I do project coordination, design, and energy modeling. And next to Lauren.
Hi everyone, my name is Lauren. I am an assistant project coordinator here at BrightBuilt, and I have been working with BrightBuilt for coming up on 4 months. And I'm really excited to be part of the presentation today.
Okay, that's the BrightBuilt team today for the presentation. I'm going to hand it over to Kurt in a moment to introduce himself and then begin his presentation. We will stop share from this slide that we have up right now and then allow him to open up his presentation and get rolling with that. But before we do, just a couple quick housekeeping items. So the format for today will be we'll be handing it over to Kurt momentarily to do his presentation, and at the end we'll have approximately 10 to 15 minutes to take questions. We will field those questions in the Q&A box in the Zoom toolbar. So if you have any questions, please put them into the Q&A form, and Audrey and Lauren will be alternating taking those questions and posing those to Kurt so that he can address them. We will likewise look through the list of questions that were posed in advance of the presentation today to identify those that weren't addressed already through Kurt's presentation. So at the end, please stick around. There will be some great content as well in the Q&A session. And then we will close out from there. And this will be available, recorded after the fact if you're interested in watching again or circling back to specific content. So without further ado, I will hand it over to Kurt. Welcome, Kurt, and thanks so much for joining us today and being willing to make some time to share all this great information.
You're welcome, Parlin, and hello, everybody. So we're going to start to screen share here. Okay, so my name is Kurt Johnson. About 15 years ago, I had seen a need for a company that would actually specialize in ventilation. I had bought a modular home back in 2001. It came with an air exchanger. At the time of buying the house, I didn't realize what it was. It was explained to me by the salesperson, and I've had a system running in my house ever since then. Side note, my wife's allergic to cats. We've had a cat for 13 years. In fact, recently we got a second cat, and she's been fine. We've been able to keep it. Can't promise that for everybody, but in our case, it's been a really good experience. So better ventilation for improved air quality. I did this before the legislature 2 years ago, so I'll do it before you guys. Does anybody think this is a good idea?
No.
Obviously, everybody knows that's a bad idea. And yet, my green screen behind me is showing what we're doing with houses, and we're basically making them as tight as that plastic bag. So improved air quality and airflow is very important. I like to cover the terms because I will use things like CFM, and when I do that, I don't want to confuse anybody. So ventilation is the process of exchanging stale or noxious air with fresh air. It is not running a fan within a room that just blows air around the room. So it's actually changing inside and outside air with the assumption that the outside air is fresh air. A cubic feet per minute is what we talk about when we talk about ventilators and air exchange rates or bathroom fans, and that's basically a 1 by 1 by 1 cube of air, okay? IAQ is indoor air quality. A physics term here is air out is always equal to air in. And I know there was a point in time I didn't think about this, but it's really important in our buildings that every time you turn on a fan and blow air out, whether it's your bathroom fan, your clothes dryer, a central vacuum system, anything that blows air out of your house, the physics involved is naturally going to push air back in to replace that same volume of air. It didn't used to be such a big issue that people would understand that, but today in the way we're building our houses, it's actually become a very important issue that we understand that anytime you blow air out, air is going to make its way back into the house, and where it comes from is very important. Pathway, air flows in, it flows out another opening, and there's a force that pushes or pulls it. And so from the ventilation standpoint, it's really important to understand that all three of those things are important if we're going to get air to flow, and then it's important where it flows from and where it flows to. Stack effect, cold air drops, warm air rises. That's a fairly strong force the colder and colder it gets. Although this time of the year, as we get into outside air temperatures that are about the same as inside air temperatures, that force is not very forceful. It doesn't necessarily move air in and out of the house. And then makeup air is basically that air I was talking about. When you blow air out, air is going to come in either a planned opening or an unplanned opening. It's going to leak in somewhere. So human beings breathe about 20,000 breaths a day. It's about 35 pounds worth of air that goes in and out of our body. We need to do that. If you think about our lungs, they're the ventilator for the body. It breathes out bad stuff, hopefully breathes in good stuff. If we don't breathe in good stuff, actually bad things will happen to us. So when it comes to a house, there's two basic effective strategies to deal with pollutants. One of them is try not to bring them in. The other one is the ones that gets in, we need to give them a way out. And that's what I'm going to talk about today, which is ventilation. I've had this in my presentation for years because people didn't really think about the things we pass from one person to another. I've always thought that was pretty important, and I knew that we were making each other sick. It's not a new thing. We've known that for hundreds of years, actually. In the last year, we've all become very aware that this is very much an issue, and hence we walk around like this to try to limit those respiratory particles, those aerosols, so that we don't blow those onto other people. And this is why filtering just is not a great solution. It has a place from an air quality standpoint, but it is not the starting point. If you go online at all, you can get very confused about what's out there. A very famous person in the building science community said dilution is not the solution to pollution. And then another pretty prominent person in it kind of countered back. I just want to deal with this. You have to be careful what the information you get is and how you apply it. So there's two terrible problems I see with source control. Number one, how do we get people to stop bringing in pollutant sources into the home? I know in my own home, I don't have total control over that because there's other people in the home who bring things in. I love my wife. She will use hairspray. She continues to use hairspray, and I cannot get that situation to stop. And the other part about this is human beings themselves are part of a pollutant source. So not only what we breathe out, but the things that we wear, put on ourselves or whatever. So I don't see that it's realistic that we can completely stop bringing in pollutants. So I see that ventilation is an absolute necessity as part of this equation. And again, if there's questions that come up, certainly I want to field them, but I also don't want to slow down the presentation. So if there's ones that I can answer quickly, I will. So dilution, which is what ventilation is part of the solution, and it's a very important part of the solution. There is a standard for minimum ventilation, and I'm not going to go into detail in this. Just understand, anytime you hear people talk about 0.35 or HRAI, we're talking about a change of air every 3 hours, which they're not saying that it's healthy at that level. They're just saying, well, we believe that being less than this is probably not in our best interest. Okay, so I just want to caution people. If somebody says to you, hey, you're hitting 0.35 and you're fine, you have a healthy house, even the standard itself does not guarantee that. Okay, and this is actually right from the standard itself. So the design of a balanced ventilation system is to incorporate every area. I'll use the term inside the warm envelope. Okay, you have a structure, it wants to shed the weather off, but not everything in that is necessarily the warm envelope. So where we seal and we try to create a warm space versus a cold space, that's what I'm going to talk about as far as a indoor air space. Now, my backdrop behind me is an attic space that used to be outside. I would consider that outside the envelope. And yet what they've done is they've spray foamed all the way to the roof peak over my head here. And now this actually has become inside airspace from a ventilation standpoint. And that can be confusing. I won't get into detail about it, but I would think that now that this is actually part of the inside space, that we need to address this at some level with some form of inside air ventilation. So a design system is going to ventilate all rooms. It's going to control the airflow. We now have the opportunity to recover heat energy or cooling energy. We actually have an opportunity now to recover the heat that we would typically blow out of a bathroom. We can have less holes in the envelope, so less leakage points when things aren't being used. We can use it to actually control to some degree humidity, I would say in our climate, 8 to 10 months out of the year. And we do have the ability to program that. And in a later slide, I'll talk about why that might make some sense. And it's very cost efficient. I won't spend a lot of time on that, but understand that to not have ventilation is from a health standpoint is way more costly than the amount of money you're going to spend to ventilate your house. So when we get into what a system is and okay, what does that look like? What do you need to do? These are really the main questions that need to be addressed. And essentially, I'm going to go through them one by one and try to give you some information to understand, well, okay, how am I going to determine the size of a unit? Why would I pick an HRV or an ERV? And so I'll go through those one by one. So how many CFMs do we need? This actually isn't a new issue. There was a couple of books written by John Billings back in the late 1800s about ventilation and heating. Basically, John had seen that if you put a whole bunch of sick people inside, they make each other sick. And in his experience, what he saw is when you put them outside or in tents and barns and had more ventilation, those people actually did a whole lot better. So the first ventilation standard actually, sorry, getting ahead of myself. Oh, did I skip a slide? The first ventilation standard was actually in 1895. And John said, if you want to be healthy, I think you should ventilate at 60 cubic feet of air a minute per person. Bunch of engineers that were working with him said, yeah, that's an awful lot of air. And they agreed that 30 CFM per person would be the minimum. And that was what became the first standard in our country. And by 1925, 30 states had adopted that as a standard. Recently, we've had studies looking at, okay, you know, what happens with indoor air. And here I point out that there was 3 different studies that looked at ventilation and respiratory illness, military barracks, in the jails, and in a nursing home. And what they saw was if you increased ventilation rates, the people did much, much better. And you can see here in the bottom part, actually 50% to 370% better, okay? So this is not a new issue. I hear people all the time, oh, I live in an old leaky home, I don't need ventilation. Well, back in 1895, they thought ventilation was very important back then. Those were old leaky buildings, what most people think about. So this is a breakdown of that. Again, I just went over it, so I'm not gonna go into it in too much detail, but I just want you to keep in mind that way back then in leaky buildings, they thought you needed to have a minimum, the 30 CFM per person is actually about twice what the change every 3 hours is, okay, to put it in perspective of what they're talking about now. And the 60 is actually a point to later on. Actually, this number is still true if you want to be healthy. So ventilation increases equal better performance. When we look at this in the workplace, there's been many studies done that would have a positive correlation as you increase ventilation rates, okay? You can see a corresponding increase in performance. So over at BrightBuilt Homes, if the employees, if there's a desire there for leadership or ownership of the business for their employees to do better, it would actually show that if they increase the ventilation rates per person up to the C60, this is modern day studies, they show that, wow, there's a better performance then than if we do what the building code shows at 20. So we can actually increase performance with our employees. And not only that, we can actually reduce absenteeism. In our schools, we can see also we can get an increase in performance. From 5% to 10% increase, when we increase ventilation rates 50%, we've actually seen in the schools an increase of a full grade level better. So I threw this slide in just a few minutes ago. And the reason I did this is going to sound like a little bit of a sidetrack, but it's really not. I'm finishing off a study that's being done out of Pittsburgh, Pennsylvania. They've been doing it for a number of years now. I have particle counters in my house. I run ventilation in my house at about a change more often than every 2 hours. So that's actively running during this. And what they were looking at is how does outside particles affect inside? Well, the good news here is in Maine, we have really good outside air. We don't have a lot of particles, okay? And you can see that on the left here. I've got a particle counter in my kitchen, in my bedroom, in my living room, and outside. And you can see outside, our air is actually really very good. But the reason I put this in a presentation is you can see the human behavior on these charts that people are creating issues inside when they come in and start doing things like cooking, preparing in the morning. So I have active ventilation going all the time, okay? I still have peaks and valleys of what happens from a particle count inside my house on an everyday basis. And this is why I think that not only should we be ventilating all the time, but it may actually make sense to increase ventilation during active periods of time in our house. If we look at cost benefits, Bill Fisk from the Lawrence Berkeley Labs, this is a number of years ago, we had this presentation, but the bottom line is he calculated that if we increase ventilation in the workspace, the productivity gains would be about 100-fold increase for the businesses on their bottom line. It will cost them a little bit of money, and you can see here $1.30 per individual to increase, but their return on their investment would be $370 for every $1.30 that they invested to increase ventilation in the workplace. Okay, down here we got scores increase. So I put that out there to be, look, there's a lot of data that would support why increasing our ventilation rates, not only have ventilation, but increasing those rates would be to our benefit. So in your own home, you get to decide. They're actually, starting July, there's actually in the building code will be a no longer a recommendation, but the code is actually going to say you need to hit at least a change every 3 hours. But I believe that a homeowner should look at their best interest and pick a system that actually has the capability of doing much higher than that, maybe up to 3 times that, because if times in your house, you may need that ventilation rate to get rid of the pollutant that you're actually generating. So that's why I put this slide in there. I think as a homeowner, you need to decide what you want in your house. You can shoot for what some engineers say, well, we shouldn't be less than this. And that's typically what you're going to hear in our industry. Okay. Well, you only need this amount of ventilation, you'll be fine. But I think from a, hey, I want to be really healthy, and that's the kind of person I am, you may want to decide that you want to have substantially more air capability. In my case, I actually run it all the time on high speed, but I think you should at least have a range there to deal with the different things you may do inside of your house. So types of ventilators. I won't spend a lot of time on this. Online, if you look at some old maps, you'll see it'll be recommended that an HRV makes sense in a cold climate. Well, there's been a bunch of research that's been done in Canada, and the end of that is not so much. And this is the reason why. So the difference is an HRV will exchange heat energy from the outgoing air and exchange it to the incoming air. And we can transfer anywhere from about 50% up to about 95% of that heat energy, depending upon how fast the system is running and how efficient the core is. But any moisture is going to transfer through the recovery core and continue on the direction that it's going. So in our climate, in the wintertime, we may have excess moisture on the inside if we're not ventilating, and we would then drive all that moisture out. An ERV, the core material not only is going to exchange the heat energy, but it is also going to transfer some of the moisture from the flow of air that has more moisture to the flow of air that has less moisture. So in the wintertime, if I'm producing moisture inside, I am going to transfer some of that moisture to the drier air coming in. And the reason that's a benefit in our climate is if you're running ventilation from a health standpoint, our drying ability with that cold, dry air coming in, when we warm it up, we actually can make our homes very dry. It's not a new issue. We used to have pots of water on the old wood stoves in houses because when we were burning air, air was going out the chimney. The cold air coming in, warming up would actually have a great drying ability in those houses. And the people back then realized we needed to add some moisture back in for comfort reasons. So for that reason is why an ERV is hands down the best choice in our environment, unless for some reason you have a high moisture level that's constantly being generated that you want the highest level of being able to get that out. My experience, a typical house, you just don't have that. I've seen houses with rivers running in the basement, older foundations, and those houses you might choose an HRV to drive all that excess moisture out. But a typical house, certainly a new built house, an ERV is a better position. There's some benefits of that, no condensate coming out of the unit, maybe a little bit more heat recovery, but I wouldn't make a big argument over that. But the bottom line is, from a comfort standpoint, it's going to head you in the right position. And if you're going to air condition in the summertime, it'll also bounce some of that summertime moisture back out instead of driving it all in. So if we were in a southern climate, an ERV still would be a good choice. It's that in-between area where an HRV ERV was kind of a toss-up. So the new map, there's the old map. You'll see this online. If you look, you'll still see it today because people haven't caught up to speed. And you can see that they recommend to your HRV every one of these cold climates all the way down to a hot, dry climate. They were saying HRV in all of these. Okay. The research done out of Canada says, oh, we got that wrong. And really an ERV is really good actually in all these climates, with maybe the exception of that hot, dry climate out here in Arizona and, you know, those areas around it. So most of our country, certainly Canada, is better served with an ERV technology. Choosing a manufacturer, just like anything that you buy out in the marketplace, you can see companies that produce a very highly engineered product, and you can see companies that produce the product for as cheaply as they possibly can. So as a consumer, I'm just going to give you this advice. You generally get what you pay for. And you can go with something like a Zender system that has no leakage. They have rubber seals on the inside, and you can pay top dollar for that. You can go for something that's flex. I don't have any flex around me. My recommendation is buy something of good quality that it's my opinion, sizable company. It's been around for a while. So if you need parts down the road, you need somebody who understands it, that they're familiar with what you're getting, because at some point in time, your unit's going to need to be serviced. And it's better to have people in the industry that know what that product is than don't. And, you know, do you need to pay top dollar? That's a decision you can make. To me, it's more important that you have active ventilation, and you're going to pay more money to recover some of your energy. But you need to have airflow. And to me, that's really important. So these are some of your more common names that you'll see out there. And any of them will move air, but you will have, you know, from the top to the bottom in those pictures. And I'm not here to promote a particular brand. We even have some units in the market that go through the wall and they reverse. And I actually happen to have, this would be in the wall. Inside you have a filter. If I can get this out of here really quick. You have a little ceramic ERV core with a bunch of holes through it that reverse back and forth. Now, I think that's a great idea for an office, maybe like my room here, which you can't see because it looks like I'm in an attic. But as far as doing a whole house, to put a whole bunch of these in a house, I just think a lot of mechanicals are, at some point they got to be serviced. So putting a whole bunch in your house. And I know this was one of the questions. So that's why I'm just going to spend a little time here. And I've had some experience of seeing people have done that. And then they called me up and came to realization that one thing pushing air around the house was probably a better idea for them than all of these things that they actually had installed. So I think it has a place, but to do a whole house with these, can it move air in and out? Basically what it does, it runs 70 seconds blowing air in, runs 70 seconds blowing air out. The heat's picked up by the core. When it changes direction, it gives the heat back off, pulses the air back and forth through the house. But you're going to need to have one in every room. So from a cost standpoint, and I know that was one of the questions, it's not going to be cheaper. In fact, it's probably going to be more expensive to try to target all your rooms with one of these, pulsing back and forth and then pairing them up. You got to wire them all together. So I think it's special application. I just don't believe it's a good idea from a whole house perspective. So where does the unit go? This is actually a picture from one of the manufacturer's installation guides, and they actually show putting it in the attic above the insulation layer. I can tell you in our cold climate, that's a really bad idea. So it may be in the installation manual and somebody may follow it and do that in our climate, but if they look in the really small print, it'll say not for cold climates. So we should not be putting these units in a cold environment. The manufacturers have told me if you're going to look at the efficiency numbers are done 70 degrees the unit, and then they run 32 degree air through the unit, give you a % recovery. Then they run 13 below degree air through the unit, give you a recovery. So that's what the specs are based on. But as soon as you take and you put that into a different environment, you're gonna change the specs on it. Okay, so you want it in a warm area of the house, and down here, you know, it's in a mechanical room. Mechanical rooms can get very busy, but a lot of times in a mechanical room, you got something else that's using air to combust and create some heat energy, and then you're blowing that out the wall. And if you're going to try to get fresh air, you really can't be near anything else that's blowing bad air out. Okay, so you got to think about this, hopefully in the design of what you want to do in your house. You know, where am I going to do this and where am I going to get fresh air? But these are the things you need to think about. I need to be at least 6 feet away from other exhaust devices, furnace, laundry, car exhaust, kitchen and bath exhaust, you know, where your grill's going to be in the outside. Some people like to grill all winter long. You don't want to put it underneath of a deck. They suggest 3 feet from a window and corners. That to hit all these things sometimes is actually impossible. But you got to think about these things when it comes to, okay, if I'm really going to get fresh air in my house, it needs to start fresh. It doesn't need to start with some other pollutant that's coming in from outside. And then the unit needs to be as close to where that fresh air is coming in, because at times the air outside is going to be 20 below zero. And I don't want to run 20 below 0 degree air through a piece of insulated flex any length through my warm house, because if condensation is going to happen, it's going to happen on that thing. So the unit should be as close to that entry as possible. Okay, so that needs to be thought about when people are doing these systems. And it needs to be in a place that's easy to service. Okay, who's going to climb up here and service the unit? Every 3 months, the filters are recommended to be cleaned. So you got to think about how easy is this thing going to be to access for me to service it, because it does need servicing. If you ignore it, it'll become a problem over time. Okay, so these are typical places where I've installed units. And you can see with each one of these, the outside runs are about as close to the unit as I can get them. And they need to be 6 feet apart. So I try to keep those as close to the unit as possible. That's typically where we go at what's called the rim joist. Sometimes contractors want to stick us on a second floor in behind a knee wall. You can do this, but somebody's got to crawl in here and open this up and try to service it. It was a contractor. This is his idea. I didn't like it, but I did it for him. So it's your house. Is a time I put it in a crawl space and came up through. I couldn't get out because we were too close to the ground to get the air. So I had to come up and go out through the wall to get outside air. But that's where the unit is. This is an old lady. There's no way she's going down there to maintain it. So she either has to call me or somebody else to come over here to maintain it. It's in there for radon reasons, but this gives you an idea of some of the places. I wouldn't recommend it, but it can be done. Here's a closet on the second floor where we went out right outside the wall. This is new construction up above the master closet. We went out not too far over here to the outside. This is actually the house. That's the picture behind me. So we put 2 units in here. This is retrofit. We put a tandem hood where it blows out the top. And you can see here, blows the bad air out the top, brings in the fresh air on the bottom, less than 3% contamination rate. And then we ventilated his second floor through there. This is my worker Mango up there. And then we ran another unit out from his basement to do his basement and part of his first floor. So in the retrofit, you know, sometimes you do need to do 2 units. This is a doctor's office I did down in Portland. Used the top of the window as the way to get the air and exhaust the air, and then just hung it in a corner. It's a rental space, so we can take this all out. They'll never know it was in there. But because of COVID, she wanted to have a high air exchange rate in her doctor's office. These are some of the old houses I do. About half my business is old houses, although this one down to the lower left, this is actually a brand new house that was a year old. She was experiencing moisture and breathing issues. And unfortunately, this is not where I like to do it, but I really didn't have any other choice. And I had to kind of really jam these in here. They didn't fit very well. But this is why planning it on the front end is better than trying to do it on the back end. Here's another case where I had to come in on the back end and limited to where I could actually do it. And I'm trying to, you know, jump around existing plumbing lines. So these are all the ways to go through, and I don't need to go into too much depth here. Yeah, this is actually an older house built in the 1800s. And again, trying to get outside air becomes challenging sometimes. And when you cut on the inside, you got to watch for those hidden things. These are typical hoods for a vinyl new house. Actually, there's a BrightBuilt house here over in Brunswick. This is something we got to be a little bit careful about. In this particular house, they wanted the air exchanger in this room and the hybrid hot water heat pump. And the problem with this is if there's no heat in this room, this is like a big air conditioner. And this unit really is not supposed to get below 55 degrees. And I was concerned about putting these two things in a room and how that was going to impact this. So we need to keep a heads up of how does my thing impact the thing that's around it. So that's kind of just, hey, let's be careful. This was a case where I put them close to each other because I had no other choice based upon what I was presented with. This is not recommended, but it's better than not doing it at all. These are things we don't want to do. Yeah, if you hire somebody to install it and it looks like that, you don't want that. And you don't want that. Okay, so design basics. Fresh air where people spend time. Bedrooms, living room, dining room, den, also supply the basement. Exhaust from closets to the, exhaust closest to the biggest pollutant sources or moisture sources. So we typically exhaust from bathrooms, kitchen, maybe the laundry. There's maybe some moisture in there. Maybe more importantly, all the chemicals that we have in there, the bleach and the other things that we use that are no good for us. We put them on our clothes and then we put the clothes on. I think we should move away from that, but it's a place that typically people store that stuff. So having an exhaust in there might be a good idea. And also exhaust the basements. How about conditioned attic spaces like behind me? I think it's a really good idea to have a flow of air through that space.
Hey, Kurt, I'm just going to jump in. We don't have any questions at the moment, but I'm just looking at the time and we're at about 12:40 right now. I wasn't sure if you wanted to move quickly through the next few slides and get to some of the content there that you have at the end for maintenance and other things. Yep.
Okay. So we put the vents, unlike heating and cooling system, high up on a wall or in the ceiling work best. Exhaust out of those and supply those. It works best from an airflow standpoint, also from a creature comfort standpoint. This is what good installation of ductwork looks like. In the retrofit, yeah, can you hide it? Yep, you can open up walls. Most of the times I do it in inconspicuous areas in the corners of closets. Maybe behind a door if it's okay with the homeowner. Sometimes we open up and they hide it afterwards. You'd never know it's there other than this jog that they had to put in the wall. Basically, we try to find an existing any space that we can to run it and make sure things are sealed. Main control devices, I'll be real quick on this. Boost switches in the bathrooms. If you're not running a system at high speed, we'll kick it on high speed for 15 to 20 minutes and then go back down to what you set at. We can look at moisture during the winter time as a reason to kick up ventilation. And depending upon how much money you spend on your controller, you can program different speeds for different times of the day. Maintenance. You move air just like your ceiling fan in your in your living room or wherever, that leading edge will pick up dirt over time. No different here. Same thing with your bathroom fan. People don't think about it. That's a bathroom fan. They get really dirty. So they do need to be cleaned every, say, 3 to 5 years. Air intakes need to be cleaned because it will pick up debris coming in from the outside. This is HVAC ductwork that can get really dirty. Ventilation typically doesn't get as dirty as that, but it does need to be cleaned and maintained. Filters should be cleaned at least every 3 months, but you'll get an idea of how quickly they'll get dirty. But the whole unit should be cleaned out on the inside at least once a year is recommended. And that's what a typical usage, this is what you're gonna say. And down here, there's a HEPA filter. This is how black a HEPA filter will get. This is what a new HEPA filter looks like. I've got a filter here from my HVAC up above me, and you can see just blowing air around the building will pick up particles. So those things need to be changed, just like in your heat pumps, there's a screen there. If you don't clean it, you'll cut down airflow and you'll lose your heating and cooling ability. So those should be cleaned also. When do I ventilate? All right, here's my short answer. How often should you breathe? I think you should keep breathing all the time. I think it's the same thing with ventilation. And I don't think you should use some less important issue to be the decider of me shutting down my ventilation. If a skunk sprays outside for a short period of time, maybe you're gonna shut it down. But long periods of shutdown, I just don't think it's in your best interest. How much does it cost? All right, I've got a really complicated thing here. You want to, download this, look at it, and go over it. Bottom line is, I'm going to give you the numbers. Between electricity and heat loss, you're going to spend $150 to $300 a year to ventilate your house at what I think is a reasonable level. That's what it's going to cost you. I think it's cheap insurance, but those are very easily, I can show you all the numbers here, but that's what it's going to cost to get this. How much for a fully installed system? It all depends upon the size of your house, how efficient a unit you want to get or how inefficient. So units are going to range from about $800 up to about $3,000. Duct work is going to range from about $800 to about $1,600, all depending upon how big your house is and how difficult the runs are. Labor is typically 35 to 55 hours. So I would say, on the very low end, maybe $5,000, $8,000 is a typical high end. It could be more than that if you got a really big house, or you buy the most expensive stuff. But that's if you're trying to set up a budget, if you said $8,000, you'd probably, from a budget standpoint, be pretty close. And if you choose not to ventilate, these are pictures I've taken from a spray foamed house that chose, it was a contractor, he didn't think he needed it. And then the first winter into it, and I saw water condensing on his spray foam inside his walls. And what concerns me is long-term moisture that can't get out. That's a threat to our buildings and a threat to the people in them. And this is garage, just a side issue. You pull your car in, it's got all kinds of snow on it, comes off, it hits the ground, it vaporizes and tries to get out, doesn't have an easy way to get out. Can be an issue, you gotta keep your eyes open. And to end it, this is a sign from Perth, Scotland, that they were putting in homes back in the 1920s. Basically was, leave your windows open all the time. It's cheaper to do that than give your money to the doctor. Those are my sources, and I'll take any questions.
Excellent. Thank you so much, Kurt. This was really, really great. I know that this will be really important content for us moving forward. We do have a couple questions in the Q&A box, as well as some of the questions that were posed in advance of the presentation through our registration form. So I'm going to hand it over to Audrey and Lauren to pose those questions to you. And thanks again. And thanks everyone who joined us today and anyone who's watching it after the fact. I'll hand it to Audrey to start.
Yeah, thanks. Thank you, Kurt. That was fantastic. And I loved your last slide with the plaque from Scotland. Okay, we got some questions ahead of time that I'm going to plow through. First off, someone is actually looking for someone to service in the Mid-Coast area for a Venmar system. Do you have any suggestions?
They probably want to call me.
That's what I thought.
Just real quick, Audrey, actually, sorry to interrupt you. Let's bounce to Lauren just real quick for the two questions that did just come in on the Q&A, just so the folks that are currently with us get an opportunity for their questions to be addressed. Sure. in case they have to bow out. But
yeah, makes sense.
Just real quick.
Okay.
All right, so our first one from the Q&A box is, should the ERV be turned off if the windows in the home are open springtime in New England?
I would say that's a decision for the homeowner, but I think the things you need to consider are, how much is it costing me to run it? Because typically when somebody talks about shutting something off, they're thinking about it's costing me money. Okay, so at that point in time, the only expense you're talking about is the electricity usage, because obviously we're not talking about heat transfer, right? You're opening your windows. So you know, we have units that literally use $3 a month in electricity to run. So if you're going to shut it down for, you know, a day or a short period of time, you got to calculate out, geez, how much am I really saving? Okay. But I would say this, in my house, I may open a window upstairs in a couple of rooms, but honestly, unless I open the windows in all the rooms, then really the airflow is only between, you know, for the most part, the rooms. My downstairs, my basement, daylight basement, is not going to be positively affected by that opening of the windows upstairs. And I always want air moving through my basement. So I leave mine on, understanding the small cost of the electricity to run the fans, because I'm concerned about having stagnant air sitting in any part of my house. So if you're on a slab and you open all the windows, that's fine. You want to shut it down. You're not going to be saving a ton of money, but if you feel more comfortable, just make sure you turn it back on when the windows get closed.
Okay, our second question, this may be better suited for a BrightBuilt answer, but the question is any of the exchange ducting done during the modular build process?
Yes, actually, I install those in some of your homes, and I've continued to work with the factory to try to get it to be efficient from an airflow standpoint, but also efficient from a on-site when we start putting things together standpoint. So there is pretty much all of the duct from the bottom part of the house up is run in the factory, and when we put boxes together, I need to go and actually connect between, you know, box 1 and box 2, box 3 and box 4. So yes, a lot of ductwork is run in the factory.
Excellent. That's it for our Q&A questions, unless anyone has any more to pop in there. Otherwise, Audrey, you can start on the RSVP questions.
Okay, great, thanks. Alrighty, one of the questions, can an ERV serve as the primary and only bathroom exhaust? And they go into specifics of their home. It says more specifically, a new build, 2-bedroom, 2-bath, 1 level with a walkout basement. The plan is to exhaust the 2 bathrooms and the ERV and supply fresh air to the wall mount indoor unit of a mini split for distribution to the open kitchen, dining, living area, diffusing through the bedrooms back to the bathrooms. Did you follow that one?
Yeah, actually I did. So code comes into play in the question. So the code says, the mechanical code, that you need one of 2 things. You need a 50 CFM switched fan, an exhaust fan, typically what we call a bathroom fan, or a continuous 20 CFM system, okay? So depending upon how your ERV system is designed and the volume that you have, it can meet the code. What I will tell you is, if you run the system because you're concerned about health issues and moisture issues that may happen in your house, so you run it all the time, it will do overall a better job of ventilating that bathroom. And 15 years of doing this, I don't have customers calling me back saying, hey, I got moisture issues in my bathroom. And I fully believe that that's because there's always a flow of air going out of that room. And so there's no good reason for moisture to linger in that room. Now, having said that, you got to think about the design of your bathroom. Recently, I had a plan on my desk that had, in the bathroom, they had a stall for the toilet that had a closable door on it. They had an area for the shower that not only had a shower door, but also had a door that could close the shower off from the main part of the bathroom. And so obviously the shower is something you need to consider, you know, okay, moisture, and you need to have that as a part of making sure that there's air moving through that space. So in that particular case, my recommendation was, well, you want to put an exhaust in the toilet spot, and you want to put an exhaust in the shower spot to make sure that both of those areas and the air coming in, you got to make sure there's at least a 3/4 inch undercut on your bathroom door, so that when the bathroom door is closed, that there's enough space there so air can come in from the hallway and then get past those other two doors. Typically, pocket doors are not tight closing at all, so that you actually don't restrict air being able to pull out of both those spaces. So there's a long answer, but the bottom line is yes, not only can it meet code, but it actually works really well as long as you keep it running. Supplying air to your heat pumps, I would say this: Europe has found that when you connect ventilation air to heating or air conditioning systems, it's just a better strategy not to couple it with something that may not be running all the time than to have it as a standalone system so that there's no interference there. So I've put fresh air into ducted systems, but I always tell the people, you lose some of your control of distribution and how that system works. It's really a better idea to have your ventilation system as a standalone system than to connect it to something else.
Thanks, Kurt. All righty, next question. We do use these systems in our home. When the temperature gets very cold, sub-zero and single digits, the system is unable to heat the air and is blowing cold air into the house. Our heat pumps would seem to be working harder to maintain a comfortable interior temperature. At what temperature should we stop using the ventilation system?
Okay, so I'm going to go back to pollutants. If pollutants are constantly being released in our houses, then if we turn off ventilation, then those pollutants are going to increase. And I showed you a chart in my house with active ventilation all the time. So in a house like this, that if I shut off my ventilation, leakage is not going to be a whole lot. Even when it gets cold, the force gets pretty strong. But if you've done a good job sealing up your house, there's no good reason I've seen to think that you have enough leakage. Of course, if you have leakage, you have the same problem, right? Now, actually, you got a bigger problem, because the leakage would be that really, really cold air not having any heat transferred to it, that your heat pumps then have to heat up. So, you know, I don't want to sound like I'm fresh, but do you not do laundry when it's really, really cold out? Because if you run your clothes dryer, you're blowing warm air out of your clothes dryer to the outside. Somewhere that cold air is coming in to replace that air. Somewhere it's leaking in, and your heat pumps have to heat that up. Are you running your range hood when it's really, really cold out? Because if you're blowing that air out, which I recommend you do, because those particles are actually, we know those are a threat to us. That same volume of air is leaking in really cold, and you have to heat it up. So I just don't think it's a great idea to stop your ventilation, which is the one thing that's reliable to make sure the pollutants in your house don't build up. You can do it, but I just don't think it's a good idea. If your heat source can't keep up, and I can go through the calculations and show you that it's not a ton of heat loss, but certainly the colder we get, your whole house is you know, the equation is challenging from every aspect of it. Okay, but to shut off the one thing that is probably best keeping you healthy in that tight house, I just don't think it's a good idea. You may, during that cold period of time, may need some supplemental heat to help you keep comfortable, but that's your choice.
Yeah, that's what it sounded like to me too, just some supplemental heat. Don't turn off the ventilation system. Alrighty.
Audrey, we have 3 Q&A questions, so I'll just pop those in
Okay.
from attendees right now. The first one was asking about the CFM-ACH recommendation slide, but just a reminder that all the participants will be getting a recording of today and will have access to that slide information, unless you have a specific question about that.
So they
The second,
go back to it. Is that what they want?
sure, we can go back and pull it up in case they have a specific question, but otherwise they will be getting that information after this in the recording.
So the question was on the recommended or
just to go back to the slide, that my understanding is to go back to that slide. And then the next question is if that looks like somebody says, we have the option of setting the exchange on our ERV one. They have 3 options on setting the exchange on the ERV, and they're wondering if there's a general rule of thumb for outdoor temperature affecting those settings or other guidance of when to change the setting.
I'm not sure I understand the question.
Let's see if we can. It says we have the option of setting the exchange on our ERV to 1, 10 to 60, 2, 50 to 100, the CFM 50 to 100. That's the supply air amount, or 3, the exhaust air CFM 50 to 100. Those 3 different settings.
Okay, so my bias is I want higher volumes of fresh air running through my house because I want to be healthy. So I would pick the one that gives you the highest volume of air through your house to be healthy.
Great. And one last one, we'll get it in. Do the ERVs provide zones or simpler, or is it just simpler to have 2 ERVs?
Yeah, it would be simpler to have 2 ERVs. Yep. Yeah, I mean, you could do zones, but it would be simpler to have 2 ERVs.
Alrighty. We'll go back to our previously asked questions. I'd like to see a comparison of a Luno system versus a ducted system. Differences in cost of units, ventilation performance, and cost of installation and operation. I'm assuming a Luno system would be less costly both in terms of installation and energy operation.
The energy operation would be challenging, but the Lunos, the last time I looked at the pricing, you're going to pay $1,200–1,300 for a pair of those.
Yeah.
Okay. And so when you start going around the house counting how many rooms you're going to have them in, it doesn't take long before you get to the price for a fully ducted system.
Yeah, and I like the comment that you made earlier about, having that one appliance as opposed to, individual appliances all over the house. Of course, if this house, if it was large enough that it needed a full system, it makes more sense, I think, to get a full system. Okay, are there special requirements to retrofit these sorts of systems into an existing home as opposed to new construction? Okay, so retrofitting for the Lunos.
Probably the biggest challenge with that is wiring them together in pairs.
Yeah.
So you've got to literally run a wire from each one to connect them to each other so that they cycle at the same time.
And
So
then
two different rooms, it's not as simple as just cutting a 6-inch round hole in the wall and sticking it in. You know, they're designed to pulse together. So you got to think about, how am I going to run that wire from this one and this wall over to the other one? One contractor's house, he ran metal conduit along his walls and inside of his house. And I looked at it, I'm like, holy mackerel, a lot of people would never accept that in their house.
yeah, and then it has to get to the main distribution panel too.
Oh yeah, and then you're right. So it's not as simple as, you know, I can cut a 6-inch hole through, you know, most walls pretty easily and slide something like this right in. But it's not that simple. I've got to now run that wire to the other one and then down to the main controller. And yeah, there's more to it than just cutting a hole and sticking that thing in the wall.
Yeah.
Hey guys, I'm going to jump in here. I previewed the rest of the questions. Look like you hit most of those in the presentation, Kurt. And if folks have other questions, we'll be sure to get some answers for them from you. We really appreciate your time today and the information that you relayed, and look forward to seeing you down the road.
All righty. Well, thank you.
So, thanks for being here, guys.
All right.
Thanks, everyone. Have a good day.